Okay, good afternoon from Australia. It's about 3 p.m. in the afternoon here. My name's Scott MacLean. I run my own small business now called NewMR Analytics, but I used to work for Research International and AC Nielsen and one or two other companies, and I've been working in advanced analytics for a fair chunk of my professional career, which now extends to 30 plus years, and I just love it. So hopefully I can convey some of that enthusiasm to you this afternoon when I'm talking about structural equation modelling. There'll be a Q&A at the end, so feel free to ask me really easy questions. If you ask really difficult ones, I reserve the right not to answer. I'm talking about structural equation modelling today, and it's almost, when I first started using this technique, it almost seemed like a bit of a black art or a dark science, because on the basis of things that we can measure, in other words, the questions we ask in surveys, we basically try to make predictions of the relationship between things we can't measure. Now, that might sound a little confusing, but if I suggest, for example, that we might conceive of some constructs or factors or things we can't observe, such as happiness and prosperity and wellness, we all know what those things mean, but being able to define them is difficult, and the way they're usually defined in market research is to ask people at least 2, preferably 3, 4, 5 questions which are associated with those underpinning constructs. But before we get to that point, we can, and this is actually what's known as the structural model, we can hypothesize some causal links between these different underpinning constructs. So we might hypothesize, for example, with a single-headed arrow, that happiness has a direct influence on wellness, and ditto with prosperity. And we might also hypothesize with the double-headed arrow that you can see there, that happiness and prosperity co-vary, or that there's a correlation between the two. And that would seem to make some degree of sense. You might argue that the double-headed arrow should be a single-headed arrow, that prosperity causes happiness. Or you might think something else altogether. It doesn't matter. The whole basis of structural modelling is that we start with an hypothesised set of relationships between underpinning constructs, latent constructs, or the things we can't observe. So what we need to do is add some measured variables which give us a means of calibrating, if you like, these underpinning constructs. You can see that I've called them indicator variables there. It means the same thing as a measured variable. And the reason they're called indicator variables is because they provide an indication of the latent constructs. So to take the top left-hand section as an example, I take pleasure in the small things of life can be said to be an indicator of how happy someone is. You'll notice the little 1 printed there. That's simply part of the statistical calibration process. There's a degree of redundancy built into the mathematics, and to make it work, you literally have to say, I'll set one link to a value of 1. That little 1 is in fact a regression coefficient. So between the underpinning construct of happiness, we have 3 simple regressions where the measured variables are predicted by this underpinning construct. In fact, the top left corner, the top right corner, the bottom, they're all examples of what's known as a confirmatory factor model. Some of you will have heard of factor analysis or principal components analysis. This is really 3 little factor analyses stuck together. And that's what a lot of structural modelling is about, undertaking and calibrating a number of individual factor models and linking them together. This is how a structural model can appear in reality, and it can get quite complicated. Again, the little numbers shown on the arrows are literally regression coefficients, and in most cases we'd be showing these as being standardized, which is what's been done with this model. This is based on an actual case study. I can't show you the detail, but I can assure you that it was one which was run within the last 6 months. That looks kind of complicated, but it's when you throw in or show in addition the measurement model, which is the outside rectangular bits, that it starts to look really messy. So you can see why we might prefer to show the model like this than like this. Now I mentioned the word calibration. What we do in structural modelling is in what's called covariance-based structural modelling. We try and predict the covariance matrix which exists for the indicator or measured variables based on the regression coefficients that we devise between the latent constructs, the ellipses in the diagram. And to determine how close we get to the covariance matrix, that sample covariance matrix between the measured variables, there's a load of different measures of goodness of fit that we can use. And it can be quite confusing and often controversial over which measure is the best one or which are the better ones. I would tend to use the four shown here: comparative fit index, goodness of fit index, the root mean square, error of approximation, and a chi-square value divided by the degrees of freedom. Now, in the handouts that you'll receive later, or the copy of this presentation you'll receive later, there's quite a detailed glossary of terms which explains what each of these things are. Suffice it to say that a colleague of mine once described the GFI, or goodness of fit index, as being a gut feel index, and that's how she looked at it. It ranges somewhere between 0 and 1 mostly, a bit like an R squared, but not really the same. The closer to 1 it is, the better. Same with the CFI, comparative fit index. The closer to 1 it is, the better is the model, or the better the fit to this covariance matrix. Now, sounding really, really technical, I know. The main thing to remember is that we're simply trying to make what you could describe as a rather fancy regression model between all these latent constructs. There's another version of structural modelling which has only arisen relatively recently, in the last 20 years, called PLS-based, partial least squares-based. There's at least 2 packages which enable you to undertake that sort of modelling, and in a sense it's a lot simpler. There's been some recent research that suggests it's not as good, but there are advantages of the PLS-based approach, not the least of which is the availability at the moment of some rather good free software, which I'll cover in just a moment. Now, the main issue that has concerned me for the past few years is this, the nature of the indicators. In what I've shown you so far, we've been looking at what's called reflective indicators, where the indicators or measured variables literally indicate or reflect the latent construct. But there's another type of indicator or factor structure called formative, and it's very, very clear when we should use a formative model as opposed to a reflective model, and those conditions are shown here. Essentially, it means that the latent construct, instead of driving what we measure in the survey, the measured variables literally define the latent construct as being an indicator of the measured variables. With a reflective model, we'd expect indicators to be associated or correlated. With a formative model, there's no requirement for that to be the case. We're literally just using the indicators to define the construct. And this is quite an important topic because, as Jarvis et al. In 2003 found, there's strong evidence that if you use reflective instead of formative, and you should have used formative, you can result in an outcome which has quite serious consequences for the conclusions drawn from the model. They went on to say, and not only that, but the estimates can exhibit very substantial biases and erroneous inferences. The emphasis in these slides is mine, but it's what Java et al. Said as a distinct warning to structural equation modelers. And also substantially inflated paths, that is, coefficients or regression coefficients, can be, as I said, inflated or deflated. So warning, warning, warning if you're not using a formative factor in your model when you should be. And some years ago I was interested in looking at what difference it would actually make in the light of Java et al.'s comments. But fortunately I found that they'd already done the work, and they literally searched 4 journals for the 24-year period, 77 through 2000, and looked at every single paper which utilised the structural equation modelling approach as part of the analysis. And you can see some quite prestigious journals amongst those 4. And what they found, I still can't believe that they did this, but they looked through 178 articles containing 1,192 constructs and decided that a significant proportion of them should have been modelled as formative when they were modelled as reflective. So the outcome of their analysis of that 24-year period was that nearly 30%, nearly 1/3 of model constructs were wrong. So you could say that if in academic refereed papers experts, academic writers, were getting it wrong, then it puts a very severe onus on us as market researchers, because we're probably as likely to get it wrong as the academic community. Or to put it more positively, we're as likely to get it right as the academic community. Now the other thing about, before I get on to that, as an example of a formative construct, we might think of customer complaints. So each of these dot-pointed frequency of complaining to a store manager, incidents of telling friends and relatives and so on. A high score on one of those items in a formative construct would influence the level of the construct, but there's no necessity for each of those items to have any sort of relationship at all with each of the other items. So you can see, again, it's slightly dark in terms of the art involved, but it behoves us to think very, very carefully about the type of construct that we're going to model in structural modelling. The other thing about formative models is that they're really difficult to analyse using the covariance-based approach. There are some special circumstances, and I've given you a link there, where I've in turn referred to other papers which show what sort of models with formative constructs can be analysed in the covariance-based approach. With the PLS-based approach, it's much more flexible. There are other advantages of the PLS approach. For example, as a rule of thumb in covariance-based modelling, we need to have a minimum of 3 indicator variables per factor. In PLS, you can have 1 or 2 or 3, or however many you like, or however few you like, and the calibration almost always works. In the case of covariance-based modelling, it will often blow up or refuse to converge to a solution, except, as I said, in very specific circumstances. In terms of software, I was talking to Ray before this event, and he asked me if I was using Lizrel, and I said no, I've never used Lizrel, although some people refer to Lizrel as a sort of generic term for structural modelling, because Lizrel was the first software that was available. The one that a lot of people seem to use, and including myself, is Amos for covariance-based modelling, and that's now owned by the SPSS company or by IBM. The other one for PLS-based modelling, there's at least 2 options there. One is as part of the Excel stat set of macros that are available for adding into to Excel. These are available from the French-based group. Or the Germans are now in competition with a product called Smart PLS. I find Smart PLS to be really very, very good. It's a little bit idiosyncratic in the way it operates. For example, to delete a data file, you are asked to remove a resource, and there are a few little bugs. It's still on beta release, is version 2.0, but the significant advantage in Smart is that you can have a rolling 3-month license free of charge. All you have to do is register at the website. So I'd exhort you to look at Smart PLS, certainly. There's training available through the Excel Stack organisation from time to time. There's training in Smart via a US-based group, and I've actually participated as a recipient of the training, and I found it very, very good. I'll actually include a link in the material that's sent to you so you can see that. And by way of conclusion, I've added here some further reading suggestions. The first is a paper I presented at the Australian Market Research Conference a couple of years ago, contrasting reflective with formative factor modelling or structural equation modelling. The second is a paper I wrote with Kevin Gray, who was with the Nielsen organisation. He's based in Tokyo, and we presented that in 1999, I think, 1997. And the third one is a very recent publication from Sage, where I've contributed 3 chapters on structural equation modelling, but there's a large number of other chapters on other quantitative methods that might interest you in purchasing that book. It's a paperback, it's not too expensive. So I thank you for your attention. I think I've actually kept to my allotted 15-minute span almost, and I look forward to the Q&A and discussion that follows.